Hi, welcome. I'm Buff López, Associate in Materials and Chemicals at Cleantech Group. Today I'm joined by Apoorv Sinha, the CEO of Carbon Upcycling, a two-time award winner of the Global Cleantech 100. Thank you, Apoorv, for joining us today.
Thanks for having me, Buff.
So I want to start off by talking about carbon upcycling and the solution that you're bringing forth. Also, can you paint a picture of the problem that necessitates this solution?
Yeah, so Carbon Upcycling is a Canadian headquartered carbon utilization company. We're now operating in a few different countries, including the States and a couple of other countries in Europe, as well as the UK. And essentially what we've been focusing on, Buff, is helping increase the optionality in the supply chains for the cement industry. The cement industry currently produces about 8% of global emissions. It's one of the hard to abate sectors. And just by electrifying our grid, we're not able to get cement to a net zero outcome. And so what carbon upcycling has worked on is these alternative materials that we found that are primarily industrial byproducts. So we focused on slags that are produced from the steel industry, mine tailings, as well as coal combustion ashes that are in many cases environmental liabilities. And in many of these cases, we're focusing on the lowest grade of these materials that are currently kind of sitting in tailings or pits, and essentially chemically activating them such that they can absorb CO2 and actually be a sink for CO2 from flue gas emissions at industrial plants, but also importantly, create an ingredient that can go into a blended cement. Because what we call cement today is really just a limestone-based material called clinker, and that makes up the heavy majority of the emissions associated with the cement industry. So with a technology like ours, our partners and customers are essentially able to make a blended cement where up to half of the material that they work with could be coming from these byproducts that I mentioned, and that allows them to get a much lower carbon footprint material over to their end customers, which could be asset developers, cities, and private developers working on projects as well.
Mm-hmm. So there's obviously a need for these types of materials. As you said before, cement production produces unavoidable CO2, right? About 60% of emissions come from the calcination of limestone, approximately 40% from fossil fuels and other small steps. But there's some criticism over low carbon cement's ability to be deployed wide scale, particularly in urbanizing regions in like South Africa, maybe Southeast Asia. Mm-hmm. Incumbents are largely placing their bets on ordinary Portland cement. So what would you say is the market for these types of materials?
It's a really good question. I think you're exactly right in that, you know, the optionality that you have for different kind of resources to get plugged into the cement supply chain does vary region by region. You know, as many of your listeners might know, most of the cement industry doesn't actually have long distances that the material travels. It is very much a logistics business. You're carrying heavy materials and usually concrete, which is where cement ends up. You know, when it gets mixed with sand, gravel, and water, usually that material will not travel more than 100 miles, right? And so it does become really important to come up with solutions that can be used not just in certain pockets where you have the right geology of materials to be able to substitute limestone, which is extremely ubiquitous. I mean, you can't find any major kind of population center, either developed or developing, that doesn't have limestone deposits nearby. And so it does make it really, really hard to displace because any other kind of alternative materials you work with have to have a similar kind of cost and I guess proximity to the final location of use, but also a cost profile that people can work with. And so what we've really kind of honed on from our perspective is to say, you know, there are three families of material that we believe can fit this criteria of being just as cheap as limestone, or in some cases cheaper, depending on the regulatory framework of that region, and also be ubiquitously available, you know, across kind of the micro supply chains that each of these 2,500 cement plants have produced. And in our view, those families are clays. These are clays that cannot be calcined. These might be a wider range of clays that are more common, you know, outside of, for example, West Africa or parts of Europe, where you might have kind of high quality clays around. But if you can activate low quality clays, that opens up, you know, the entire world. Additionally, steel slags, which I mentioned briefly in my intro, you know, cement and steel kind of go hand in hand because you kind of need both for infrastructure. And what we're seeing overall, especially in the developed world, is most of the regions are building up enough scrap metal that they're able to electrify their steel production. And that slag that comes from electric arc furnaces thus far has not been a great cementitious material. It just gets crushed up to be used as gravel. And what we've shown with our technology is that we can actually activate that material to become a precursor to make a blended cement. And the third family, which is probably more relevant for the global south, where there's still probably at least a midterm horizon for coal phase out. And with coal combustion ashes and more interestingly, waste to energy plants that produce incinerator ashes, we're doing a huge amount of work in that space as well. Because again, our view is that you're gonna, every time you burn something, whether it's your garbage or coal to make power, which hopefully keeps getting rolled out and phased out, our view is that you're going to create these industrial byproducts that can be chemically pretty good precursors to make these cements. And so you might find a cement plant that has access to one of these three materials. It's very unlikely that they'll have all. But if you develop, in our view, a technology platform that allows you to kind of move all of those along, then it gives that optionality that many of these multinational companies need. Because to your point, they're not looking for a solution that works for 2 out of their 50 plants. They want something that they can start kind of codifying or standardizing all across their operations.
So one of the biggest barriers I understand for low carbon cement materials is production at commercial volumes, right? In 2023, the International Energy Agency said that less than 3% of the total cement production was low carbon cement material. And I understand
and primarily because they're burning natural gas instead of coal or petroleum coke. Yeah.
So when can we expect commercial volumes of low carbon cement materials?
It is beginning to happen already, I think. To your point, it's extremely small compared to the scale of the cement industry. I mean, we produce about 3.5 billion tons of cement a year. So for a company like ours, like Carbon Upcycling, we've got 2 demonstration facilities running in Western Canada, and we're producing 20 to 30 metric tons a day of this cementitious product that's going into the field and has been able to kind of meet the regulatory standards that are required for this to be used commercially. But again, 20 to 30 tons, whereas an average cement plant produces 3,000 to 4,000 tons of cement a year, like you're still, or a day, sorry. So, when you got 20 to 30 tons versus 3,000 on a daily basis, you've still got a lot of scale up to do just to be relevant at one plant. And then there are 2,500 plants. So we're very much in the early innings of kind of what needs to happen in cement decarbonization. But what we're finding is that more and more these supply chains becoming tougher and tougher to manage is creating more of an impetus for these companies to look at new solutions. Right now in most of North America, including in the States, over 25 million tons of cementitious material is imported from offshore, coming in as far away as Japan, Indonesia, Vietnam. And our view is, and some even from China, and the thinking is that is going to become a major focus, we believe, over the next 5 to 10 years, that people are going to want to domesticate these supply chains, use all the economic value that's created to create local jobs. And so we're hopeful that, although the numbers are just creeping into the tens or hundreds of tons per day kind of range across the whole field, in the next 3 to 5 years, we'll see a big influx of more deployments and as such, hopefully a much larger impact.
I used to think of cement as simply a consumer good, right? But I've now come to understand it as a little bit more of an infrastructure. We rely on it so heavily for our survival needs, especially in developing regions. Can you talk to me a little bit about the importance of investing in that infrastructure?
Absolutely. I think you're exactly right, Buff. I think, there's been a huge focus in the last 10 to 15 years around digitization, kind of digital tools generally to increase efficiency of processes. And of course, there was the Internet of Things kind of movement, and now we're talking about how AI can help with a lot of those changes. I think in all of this, our view is that some of the heavy industrial kind of sectors that have really made up a lot of our infrastructure, they've been kind of neglected a little bit. If you look at the market cap of the major steel companies, the major cement companies in the last 2 decades, they haven't substantially moved. In North America, it's a bit of a different story where there's still been a bit of growth, but globally speaking, there has been a lack of investment kind of drive in those areas. And our view is that, decarbonization is actually a way of not only helping with the climate goals, which, sometimes can be ignored or kind of sidestepped for other more immediate priorities. Our view is that we're going to have to do a lot of infrastructure development, not just in the developing world and in the global south, like you mentioned, but also in the developed world, because so much of our infrastructure is aging. And so we actually think that, it's been maybe almost a decade too long since we've taken that seriously. But there is an opportunity here to not just decarbonize and do it well, on behalf of the environment, but do it in a way that we can create more sustainable, climate resilient infrastructure as well. In fact, most of the cementitious materials that are being added into cement now, into clinker kind of heavy cements like OPC, are primarily being driven not so much by not directly being driven by carbon related mandates, but more so because these additional materials actually improve the durability of that Portland cement. And so our view is that, ultimately you're going to have to take a very holistic view. But I think from a policy perspective, from a long-term kind of investment standpoint as well, from the private sector, this is an area that could create some really interesting investment opportunities and growth over the next decade.
Yeah, definitely resiliency is a whole other conversation, right?
But cement's such a big part of it, right? Because it's one of those things where if you don't build better than you did, 60 years ago, when you were last kind of doing a new bridge or something like that,
same problem's going to come out.
Exactly,
Yeah.
and there's a higher likelihood of 1 in 100-year events and things like that. So we really have to not just move quickly, we have to do it really well and do it right. And I think that's going to create some really interesting opportunities for the right solutions to get kind of sped up in deployment.
Couldn't agree more. Thank you, Apoorv, for joining us. It was a great conversation.
Thank you so much.